Okay. All right, so first example, integrate. So we'll focus on just understanding how to sub and what type of questions we'll see. So 4 over x minus 8 dx. So let u equal x minus 8, du would be equal to dx, correct? So that 4 is just in the way. So what you can do is pull the 4 out here. And then this will be du over u. So the integral would simply be 4 ln of x plus c, right? See how it's not too bad, right? Once you do the sub. Is there any question on this problem?
Shouldn't it be x minus 8?
Oh, yes, thank you. Technically, actually, it should be u, and then we sub it, right? Bring it back. Thank you. All right. Well, let's move on, if that makes sense. Okay. This guy will require a little bit of algebra. Okay, let's try to make it write a little neater. X squared plus 5x minus 5 over x minus 3 dx. Okay, so this one kind of sucks because you have to do a long division in order to rewrite it. Do you guys remember how to do the algebraic um, long division?
Yes.
So if you're comfortable with that, this will be no problem. If you have forgotten or never done it, then this will be a little bit annoying. So basically, change work on this part here. Divide it this way, and just remember the algorithm, right? If I have 5 into 595, well, I go into the first number, negative number. 1 times 5 is 5, and then you do the opposite sign. You subtract it. Then you bring down the 9. 5 goes into 9 one time. 1 times 5 is 5. Put the minus sign. You just keep doing this, right? You remember? 5 into 45 is 9. In 9 times that, whatever, then you're pretty much done. So it's going to be the same pattern, except you will only divide with the x, but you will multiply the whole thing as you go through. Also, make sure that every single power is there before you start. So you have 2, 1, 0 power. So we're good. They're in descending order, nothing's missing. If there is a power missing, you got to put a 0 as a placeholder. Like, for example, if this was x squared minus 5, you would put a 0x there. But we're good, so don't worry about it. So x divides into x squared, and you get an x, right? So there's my scratch work over here. So x squared divided by x is x. And then x times these two gives me x squared minus 3x. So minus plus. So 0, right? X squared minus that, 5 plus 3. No big deal. Then you start again. X into 8x would be 8, right? So positive 8, yeah, plus 8. 8 times all that nonsense is this. It's opposite sign. 8 times negative 3 is 24. Swap the sign. Bring down your negative 5 because you can't subtract otherwise or add. 8 minus 8. You guys remember doing this? If you don't remember, I will send you a video on more details.
Yes, sir. Please do that. Yes, please. I appreciate it.
Okay, I'll do that. Because honestly, I didn't learn this until Cal 2, and and that it was a pain in the ass. But you're supposed to learn this in like I don't know, freshman year or something.
Yeah,
I-
I
But
feel like I learned this in high school. and
yeah,
That's-
it's
never
supposed to
used
be
it
in high
yet.
school, this part. But it's all good. If you didn't learn it, I'm not going to judge you because I did not finish high school. So, whatever. Let's see here. Where's my. There we go. But anyway, well, actually, maybe I'll show it down here. That'd be better. So, once you've done this division, you have a remainder, right? So, the way you write remainder is over the divisor. So, what we're doing is rewriting this guy. I'm trying to go over it a little bit, but I don't want to spend too much time on this. So I will send you a detailed video soon. So this division becomes the quotient plus your divisor, plus the remainder over the divisor. So we're going to integrate this instead. This is much more doable. This is not. So what we're doing is basically integrating this instead. See what I mean? But I'm not going to write that because I don't have space. Once you have done that, so basically you get integral of x squared plus 5x minus 5 over x minus 3 dx. And you switch it to the integral of x plus 8 plus 19 over x minus 3 dx. Sadly, I'm out of space here and I'm kind of forcing it, but I will rewrite this on this other side, make it more pretty. So we did the division. Let me rewrite it one more time on this guy. And then we changed it into this problem. That was x plus 8 plus, was it 9? Yeah, 9, right? Or 19. 19. Okay. So integrate the x, that'll be easier. And it's just x squared over 2. Integrate the 8, that's just an 8x. But what is this guy going to be? So let's do this one separate. The first two are just basic power rules, right? You have any questions on how I went from here to here?
Yes, actually, could you repeat the second step, please? Oh, I'm sorry, the first step to the second step.
From here to here?
Yes, sir.
Or, okay, so first from here, we did the long division that gets us this. So that will require some long division review if you don't know how we got here. And then this step to here, we do the integral of the x. So antiderivative of the x.
Okay.
Remember how you add 1 to the power, and then you divide by the result. So the way we were showing it when we first did this a couple of lectures ago, we said 1 plus 1, right? Over 1 plus 1, you remember?
Yes, sir. That was
And-
yeah.
And then derivative of 8x is 8, so the antiderivative would simply be 8x.
Okay.
So then once you get here, we got to integrate this guy. This is the new stuff. This is the ln integral we got to deal with. So let u equal x minus 3, du is dx. So pull out the 19, do your substitution, and then integrate. Integrate to find the ln thing. Excuse me. So that'll be 19 ln of u plus c. So that'll be x squared over 2 plus 8x plus 19 ln x minus 3 plus c. Is there any steps here that don't make sense, or if you might have missed it?
Yeah, actually, where did the x minus 3 go in in dx? So it's 19 over x minus 3 dx.
Yeah, so we gotta sub this guy. So you let u be this bottom part, and then you do the derivative. So this is the substitution section in 5.5. We're using it to make the ln integral easier. So we sub the bottom, the denominator. We replace the dx with du, and this is the formula that we wrote at the very beginning today. This is just simply ln.
Oh, okay. Cool.
And once you have that, you bring back the what u actually is.
Okay. Yeah. I get it. I appreciate it. Thank you. I was lost, but thanks.
No worries. Please ask questions whenever it doesn't make sense. Not a big deal.
Yes, sir.
But yeah, that's it for that guy. Anybody else have any questions on it? We'll do some more integrals here in a second. Okay. This is a little tricky. We can go a little slower on this one. Integrate the integral of 4 over x ln x cubed dx. So right now it looks kind of nasty. All right, well, how the heck do I integrate this, right? So what you gotta pick a very clever u that will help you out. So let's see here. Actually, here we might have to do a multiple sub. Yeah, let's see how it goes. I'm gonna let u equal x cubed. I'm not entirely sure how to do it yet, but we'll figure it out. Du is 3x squared dx. All right, so there is no 3x squared in here, right?
No. But there's a
U
x
equal
minus
ln
3.
x to the third.
What's up?
Couldn't u just equal ln x to the third?
If you did, you would have a chain rule to deal with when you make the du. So you'd have 1 over x cubed times the derivative of x cubed. So if you chose that, it would make it, the du would be just really nasty.
Oh,
So let's try to do some algebra here. So maybe it'll work out. So use this. If I solve for dx, because there is no 3x squared there, I'm going to replace dx with this guy and see what happens. So I'm going to get to here. This is a weird question, just FYI. I still have an x. I think, yeah. So then this guy would be ln of u, but dx is replaced with du over 3x squared. So now I have 4/3 I'm going to pull out because it's not doing anything. So I have du over x cubed ln u. I skipped some algebra steps here. Do you see how we got there?
Yes, sir.
Okay, so I'm sorry, what's up?
No, I just said yes. I see.
Okay, good. And everyone on board with this part?
yes, sir.
Yes, sir.
All right, so then this is just u, isn't it?
No. Oh, actually, yeah. Because u is x to the third. Sorry.
So we're good, right? We don't have any more x's.
But don't we? Isn't u still x?
We've completely subbed u.
Oh, okay. Sorry, I
how-
didn't know what we're doing. Yeah, sorry. Yeah.
So we got rid of the x's, x cubes. So this is a little bit simpler. But we still can't integrate this, can we?
Right? I don't know.
So I'm going to do a double sub. Let w be ln u. dw will be 1 over u du, or du over u, right? Same thing. I know that's weird, but just hear me out here. So du over u is right here. That is dw, isn't it? Ln u we define as w. Now this is something we can integrate, isn't it?
Yep.
What is this integral?
Mm,
Is it negative tangent?
It's not a, well, hold on. Remember, we're in the ln section, right? So dw over w, dx over x. What was the integral? The same thing, right? Isn't this ln w? See what I'm saying?
I'm sorry. Is that absolute value of W? Is that what that
Yeah.
is? Oh, okay.
Technically, unless they tell me, they might have in the question, but we should put absolute value if they don't mention it.
Understood.
If they don't define x, I mean. But once you get here, w is technically ln u, isn't it? This is ln of u, which is super weird, but that's what it is. That looks ugly. Let me write that better. I'm not going to write the absolute value just because it looks funky. So this will be ln of u plus c, which, and then u is technically 4/3, technically x cubed. So this one's like a really weird integrals because we had to do a double sub. So we removed the u to have a simple, right, these first few steps was to get just the u's, no powers. But then we're like, you know what? This can't be integrated anyway, so let's sub one more time, which gave us an easy ln integral, which was this answer. But we got to sub back to u and then back to x, which makes it look really funky. Are there any steps there that don't make sense?
I think someone suggested using ln x to the third before. I
Uh-huh.
think that actually works here because once it simplifies, it becomes 3 over x, and all you do is just multiply by, I think 4/3. It's like the same concept, but just
No, I mean, if it
different way
works,
of
then
doing it.
that's totally fine.
Yeah.
Maybe I just didn't catch it. But sometimes you do have to sub twice. But maybe here you don't have to. Anyway, you guys understand the basic concept of the ln integral. Right? The whole idea is make it look like this, right? And then integrate. That's pretty much all we're doing. It's just the subs sometimes require you to be clever or do some algebra like we did here. This one required heavy algebra and then a sub. Any questions on 5.7? It's pretty much the whole section. It's just do an ln integral, sub when you have to. If you don't have to, then great. That's pretty much it.
Will we see a problem like the one we just did on the test?
I would not want I don't know. If I did that, that would be by accident. That would not be a good test question.
Okay.
And it's like, I think a really douchey question, like it's really difficult, like a really long. You know what I mean? It'd be better to give you that on a homework question, as a homework question, not as a test question.
Yeah, because that would take a minute.
Yeah, like if it was a take-home test, yeah, I'll give you some weird stuff, but not here. Okay, so 5.in is inverse trig function. So basically, you just need the formulas, and you gotta set up the question, and then apply your formula. Okay. So here are the formulas, and let me give you the. Let me define everything. So let u be a differentiable function of x. And let a be greater than 0. So number 1, the integral of du over the square root of a squared minus u squared is equal to the arc sine of u over a. Or if you prefer to write the sine -1, that's fine. It's just sine inverse, right? I prefer arc sine just because this doesn't confuse people like when they write, the negative symbol. And either way, however you want to write it, du over a squared plus u squared is equal to 1 over a arc 10 of u over a plus c. Number 3, integral of du over u square root of u squared minus a squared. That would be the secant, 1 over a arc secant absolute value of u over a. All right, so basically it's going to be one of these 3 throughout the whole homework. It just might be different levels of algebra required or u substitution. So you're going to have to do, so 5.7 and 5.8 assumes that you're pro at substitution from 5.5, which might not be true, but you're going to have to get better at sub. Okay, if you're not already. Example 1, so the integral of dx over the square root of 2 minus x squared. Okay, so it looks like, which one of the 3 formulas up top? What do you think?
The first one.
Yeah, I think it's the first one because a is some number. U is a variable. There it says function up here. So this is like my a minus u squared. Except the number is not a square, so we got to force it, right? Technically, we can rewrite square root 2 squared as a 2, right? So we will rewrite this question as the square root 2 squared minus x squared. So now it's similar, it's set up just like number 1. So there's my a and u. So the answer will be arc sine of u, which is x in this case, over a, which is root 2 plus c. So all we're doing is using a formula. You just may need to set it up or do a substitution. Okay. Okay. All right, let's go to the next one. There's no questions on this one. Okay. Number 2. It's 1 over x times the square root of 9x squared minus 4 dx. So which one do you think this one looks like? I wrote that x kind of weird, but
Third one.
Yeah, number 3.
yeah, it looks like we'll be using formula 3, so we got to make sure it's set up. Yeah, it's the only one with a variable outside. All right, so it says that we need to have u squared, and then there needs to be a u out here. So we're going to have to do a u sub before we do anything to make it happen. So let u equal 9x squared du equal 18x dx. All right, I don't have any, well, actually, I'm sorry, that's not a good idea. Well, hold on 1 second. Let me think about this. What's a good way to sub here? I think u should be 3x, not 9x. So I don't solve these beforehand. I just kind of figure it out as we go together. So this will be, I'll try 3x. So du will be 3 du, or dx, right? So du over 3 would be equal to dx. Let's see if this works. So 1 over, I'm going to put du over 3 as the replacement for dx here. Down here I have x, so I should solve for x. So if u is equal to 3x, x would be equal to u over 3, right? You agree with that? Solving for x. So this guy is actually u over 3 square root. And this is technically 3x squared. So we'll replace that with u in a moment. Just so I'm writing an extra step so you can see it. So du over 3, you can pull that out as a third, right? 1/3 down here is the same as multiplying by a 3. So here we go. So now I have du over u times the square root of u squared minus 4, which I will rewrite as a 2 squared. There we go. That's better. Okay. Now, before we go any further, are there any steps here that are weird or confusing? Do you see how we got here to there?
I understand how to do the process, but I'd like to know how come you chose 3, just out of curiosity.
The 3x?
Yeah, just let u be 3x.
Well, at first I didn't choose it, but then I started thinking, you know what? I need to have a u squared inside, right? So I figured, you know what? If I rewrite this as 1u squared, then I'll be good, as long as this also becomes a u. So yeah, I'm going to give it a
Hey,
shot.
Becky.
Oops, sorry, I'm not on the screen. So basically the idea is I want to change this into a u squared. So I chose 3x because this can be rewritten as something squared.
Oh, okay.
And once you've done that, like as long as this u appears out here, then you're good. If it didn't work out here, right, then I would need to pick something else for u.
Okay.
But now that we're here, these 3's are gone, so who cares about that? this right here will be arc secant, right? 1 over a, which in our case, a is 2. Arc secant of the absolute value of u over a, which is 2. Replace the u, and we're done. So you get 1/2 arc secant of 3x absolute value over 2 plus c. So all we're doing is using formulas, but we have to either do algebra to rewrite it or do a sub and algebra, or maybe just a sub depending, to integrate. Are there any questions on number 2? All right. Okay. Let's move on to the next one. So 1 over square root x times square root of 9 minus x. Let's see here. What should u be? It looks like it might be either sine or arc. There's an arc sine or arc secant. But this one seems like a tricky sub. Yeah. Okay. Yeah, this one's weird. So I picked the weird ones on purpose because, those are the ones you're going to get stuck on. So let's let u equal square root x. And the reason I chose that, because right now you're probably wondering, well, how did you know that, right? Well, I'm thinking that this can be rewritten as 9 minus square root x. Actually, let's rewrite both while we're at it. All right. So this is what made me choose this u, because I can rewrite that x. So this is my a minus u squared. So that is going to be the sine setup. But this is in the way, so let's see how this goes. So let u be root x. So du would be, what? 1/2 x to the negative half, right? Doing the power rule, which would become 1 over 2 root x. I don't have du. don't have a 2, so I'm going to multiply it over here. 2 du is equal to 1 over square root x, excuse me, dx. So here is my dx that I forgot to write. So this guy is right here, right? You see that?
Yep.
And this is the u that I chose. So it looks like it's going to work out. So we're going to have 2 du replace that whole thing I circled. And we're going to have square root of 3 squared minus u squared. Now we're good to go. What formula is this?
Sine, right?
Yeah, this is sine. So that'll be 2 arc sine of u over 3. But u is a dummy variable, so who cares about that? U is actually root x over 3. Now, are there any steps that didn't make sense or were confusing? You guys cool then? Does it make sense?
Yes.